Hey guys, I'm gonna be discussing you a problem in one of my school test exams, and the question is as follows: the derivative of fg is blank f prime g prime, and we have three choices. We have always, sometimes, and never. So for this problem, I answered sometimes, and you're gonna see why I did. But the answer that was also manually checked was in fact never. uh, this enabled me to have a score of 0 out of 1. So meaning I was marked manually marked 0 points in this question. Yeah, so first is let's try to understand this problem. Basically, this problem is asking you when, or like, is at the derivative of fg equal to f prime g prime, like just blatantly. And there are like many interpretations for this problem, but we'll go for the interpretation that literally just uses what is indicated in the problem. So my interpretation for this problem is, well, when is the derivative of fg equal to f prime g prime? And my answer to that question is sometimes. The other interpretations would be like the general formula of the derivative of fg, or the product rule, is f prime g prime. And well, that is obviously never. Or like other interpretations would be like f and g are like can be any function, and that answer is in fact never. But for this case, like, we have a choice of sometimes, and as a mathlete, uh, I would try to like investigate or like rule out the case for sometimes, because it's not clear whether it's really never or sometimes. Well, it's definitely not always, because you know it's not the product rule. So I actually defended to my teacher that, well, if f and g are constants, we clearly see that those are solutions. Like, yeah, the derivative of fg would be 0 and f prime g prime would be 0. And well, there's no response to my defense, and still I was still marked the day after that to be 0 marks out of 1. And that tells you that I'm considered incorrect with my defense, or at least, like, my defense was incorrect, yeah, or maybe it wasn't considered at all. So for this video, I'm gonna be defending why my answer is sometimes, and maybe why this problem should be actually taken out of the test, or like maybe consider my answer, right? Or yeah, it depends. It depends on the action. So yeah, so let's start with, like, you know with my interpretation, that we can suppose, right? Suppose that the derivative of fg is equal to the derivative of f times the derivative of g. And why are we supposing? Well, we're going to try to find a solution for f and g. And to do this, we can think of it as like a separable differentiable equation. Like, let's just hope it's separable and differentiable, like, like solvable in terms of f and g. And well, my idea is to isolate one function, and let's choose that to be f, and we equate it uh, in terms of g. So yeah, by the product rule, the left hand side will be f prime g plus g prime f. That will be equal to f prime g prime. And by transpositions or algebraic manipulations, we have f prime g prime minus f prime g will be equal to fg prime. And notice that we can factor out f prime, and this is equal to fg prime. And we can separate f and g. We can do this by dividing f and dividing g prime minus g. So we have f prime over f equals g prime all over g prime minus g. And we can integrate both sides. We have the integral of f prime over f. And we need to be careful. Let's say this is in terms of x. And since it's in terms of x, like let's do with respect to x. And this is equal to the integral of g prime all over g prime minus g dx. And here, this left-hand side is actually, like you can get the antiderivative of f prime over f. And we can do this by inspecting that, well, this is just the integral of 1 over f df. Why is that? Because, well, the differentiating f, that is just df over dx. And we get that df is equal to f prime dx. So that's, by the substitution we have df. And we can equate it to the right hand side. And here we can get this integral. This is the natural log of the absolute value of f plus some constant c. So like we can transfer it to the right hand side. So we have the integral of g prime all over g prime minus g dx plus c. And here we can exponentiate both sides, right, and negate the absolute value. So we have f equals plus or minus exp of the integral of g prime all over g prime minus g dx plus c. And we can suppose that, well, e raised to c is equal to a. And we have the final formula for f to be plus or minus a exp the integral inside. And we can set g to be a fixed function because, yeah, we're trying to solve for f, right? And let's say like g is a fixed function. And by that, I mean we can investigate g, like a class of function g. And let's just think of classes of functions. Like we have like polynomials or like exponential functions or logarithmic functions, trigonometric functions. But we'll use one of the most simple functions, right? So like let g be equal to x raised to n, right? So it's one term of a polynomial. And we're going to find f, right? So here we can substitute g. So note that g prime is equal to nx raised to n minus 1. So you get that f is equal to plus or minus a exp of the integral of n raised times x raised to n minus 1 all over nx raised to n minus 1 minus x raised to n dx. And we see that the integral inside is the function inside, or the integrand. You can cancel out x raised to n minus 1, right? So we have that the integral inside is just n all over n minus x dx. And this is you can get the antiderivative of this function, and that's simple. This is a linear function. You can get the derivative of this, so this is -1, right? And then like you can bring outside n, so we have that this is a exp of the integral of like here, so exp of -n, right, times the integral of 1 over n minus x. So that is just simply uh, -1 times the natural log of the absolute value of n minus x, and we add like plus c. But like literally we can negate that plus c, right? So we can write the final, not really the final, but the function as b times e to the xp raised to ln, the absolute value of n minus x. And we can raise this to -n. Let's go to the next page. Like let's take note of this equation. And using some logarithmic properties, we get that f is equal to plus or minus b, and we can cancel the natural log of n minus x, right? So the natural log and the exp. We're left with the absolute value of n minus x raised to a -n, or plus or minus b all over, like we can negate the absolute value because we already have a plus or minus here, right? So what we can do is, this is just n minus x raised to n, and this is our final function for f. So my point is, right, so I'm claiming, so claim is that when g is equal to x raised to n, right, and f is equal to plus or minus b all over n minus x raised to n, then the derivative of fg is equal to the derivative of f times the derivative of g. And we can check that, right? We can check that, and uh, that g is equal to x raised to n, and f is equal to let's pick one of this, and let's pick that to be the positive version of this. So we have b all over n minus x raised to n. So we check derivative of fg, right? We can use the product rule, or like you can combine it and then use the quotient rule, but that's kind of too hard. So we can use the product rule. So the product rule, let's do g, so x raised to n, times f prime, so the derivative of this. So what is the derivative of f? So let's do df over dx. Um, this is, negative b all over n minus x raised to n plus 1 times the derivative of the inside, that is just -1. So this is b all over n minus x raised to n plus 1, I think. Is it? Yeah. And we can multiply that. So we have here as b all over n minus x raised to n plus 1. And then we can add f. So we have b all over n minus x raised to n times g prime. So that is oh wait, this is times n. Yeah, this is times n. Sorry. So this is times n. And yeah, this is times n. And then we can multiply by n times x raised to n minus 1. And we can simplify this a little bit more. That this right here is n x raised to n b all over n minus x raised to n plus n plus n x raised to n minus 1 b all over n minus x raised to n, yeah, raised to n. And let's go to the next page. Like what we can do here is to get the common denominator and like combine both fractions. So we end up with fg prime be equal to, like here, n minus x raised to n plus 1. And we can multiply n plus 1 in the numerator of the second fraction and like combine it with the numerator of the first fraction. So we have nx raised to n b, and then we add plus n times this, just n squared x raised to n minus 1b, and then times n, negative x, right? It's going to be negative n x raised to n b. So yeah, here, minus n x raised to n b. And here we can cancel both of these terms, and we're left with n squared x raised to n minus 1 raised to times b all over n minus x raised to n plus 1. And now let's check it with the right hand side. And note that f prime, right? F prime, yeah, g prime would be equal to n x raised to n minus 1. And f prime, we know that, right, here, that is equal to nb all over n minus x raised to n plus 1. And here we can multiply both of these. So we have n squared, right, times x raised to n minus 1 b all over n minus x raised to n plus 1. And wow, we see the resemblance, and we checked that this is true, that the derivative of fg is equal to f prime g prime if g is equal to x raised to n and f is equal to b all over n minus x raised to n. And now we see the solution. So really, our final claim, would be fg prime. Like if we check a lot of classes of functions or test it, then we have that fg prime is equal to f prime g prime if and only if f is equal to plus or minus is it a or b? Yeah, b exp of, well, no. So it's like a, yeah, a exp of the integral of g prime all over g prime minus g dx. And g, yeah, and this is our final claim. So we can check like a lot of classes of functions, like let's say g is equal to cosine x, or like g is equal to a times e raised to ax. So I saw this examples from one YouTuber. I linked it down below, and we in fact see a solution for f as well, and it satisfies this equation. So yeah, the moral of the story is probably like, if in fact I am correct and the other YouTubers are correct, then with my interpretation, like with my context, the answer would be sometimes. And I guess to fix this question, like maybe indicate a little bit more, or if not, like just trust the answer to be sometimes, right? If this is the if this is only if this is the only indication in the problem, then the answer would be sometimes. Like it's not going to be never, because I clearly show you that there exist like solutions for this. So maybe to fix the problem, like let's say like f and g like can be any function, you know, or like the general formula is blank, like blank f prime g prime, and well the answer would be here would be never, and from the other fix that I showed you, then it's also never. And that's just a pretty simple fix, like just indicate a little bit more. And if not, then well consider some answers, like consider my my defense, like it's not that hard to do. So yeah, that's about it. um I guess I'm still marked as 0 out of 1, but it doesn't really matter. Like the point of this video is to like check the validity of maths. Like just have to respect maths and not really conclude a lot, like just blatantly just like thinking about intangibles, like oh, I'm telling you, like I'm examining I'm examining if you know f the product rule, like I'm examining if you know the derivative of fg. And the funny thing is, like, people are gonna laugh at me when I answered sometimes like, oh no, you don't know the product rule, like that's bad, right? Because it's not f prime g prime, that's not the product rule. Like, wow, you don't know the product rule. But in fact, like if I show you like my answer to be sometimes and this solution, I actually use the product rule a lot. Like I think I use it twice, so maybe that's not a lot, but I use it twice. And see that uh where is it? Yeah, here. I used it also here. And see that, well, I also use like integrations and separable DEs. So it's not actually that. It's the trickiness of the question. Like I know the product rule, but I'm just being a little explorative of this question. Like this is really tricky. Like it gives you a choice of sometimes, and definitely you have to rule out that. Like you cannot just like consider never, because it's really hard. Like f and g's, it can be any function. Like you can try any function. Like for example, you tried one function and then it didn't work, then you'll answer never. That's not true. Like what if there are solutions? So obviously it's not always, because we can like check it for some functions that it in fact doesn't work. But yeah, that's the moral of the story. Maybe like be a little more, you know, crucial in these types of exam questions. And probably if you don't want like some hassle in like defending your answers, probably answer what you think is the answer in the exam. But that's really creating a, an unhealthy relationship with math. And yeah, that's very dangerous in the future if you just like let things happen, or like accept things without like completely proving it. Especially in mathematics, like it's really easy to prove and disprove. Like it's possible, although there are problems, or like there are conjectures that you can't prove or disprove. But like it's mathematics, it's not like social like societal issues, or like political or history. It's math. Like it's pretty easy to like get an agreement, or like yeah, it's like a unanimous agreement, although there are a lot of debates going on in mathematics. But for this question, it's very easy to settle a real answer for this question. So yeah, that's all for the video. I hope you guys learned something about this video, like about this question. And yeah, that's about it.